So we have done our 3 chapters, and after this we are doing our review exercise. This is very important regarding our exams point of view, because this is all the old papers, old questions from the previous one exams. So first of all, the functions f and g are defined by. Okay. I'm writing it. Our f of x is equal to what? Our f of x is equal to 1 minus x under root, and our g of x is equal to what? This is equal to x plus 2 over 3 of x. So first of all, we want to find our first one is what? F of g into 3 is we want to find. So first of all, basically to going to this one, we are want to find the their composition of that one function. So f into g of x. So g of x is what? X plus 2 over 3 of x. So we are replacing with x with this one. So our function is, this is 1 minus x plus 2 over 3 of x. 1 minus x over 2, x plus 2 over 3 of x. So it gives us, you know, oh, no, we are taking our LCM in under root. This is 3 of x. So 3 of x minus x minus of 2, minus of 2. And look at it here, 3x minus x, this is 2 of x minus 2 over 3 of x. This is taking under root the both sides. Okay. Okay.
Yes.
Now our target is we want to find the f of g into 3. So our target is f of g into 3. That's mean we replace x is equal to 3. It's mean we are replacing our x is equal to 3. X is equal to 3. So we are put it in this 2 into 3 minus 2 divided by 3 into 3 taking under root. So it gives us, 6 minus 2 over 9. So, this is 4 over 9 of under root. 4 over 9 of under root. 4 under root is what? This is 2, and 9 under root is what? This is 3. Okay. So can you get it? If you can go through it, I'm giving you the time. You can go it.
I'll go through this once and I'll write it into say. Just give me a second.
Okay. Okay. Mhm.
Can you scroll down a little bit, see?
Okay.
Yes, you're done.
Okay. Okay, now I'm moving to this B part of this one. Basically, here we want to find the G square of X. So basically, G into G of X we want to find. So G into G of X. So G of X is already given our X plus 2 over 3 of X. So we are replacing our with so this is basically composition to itself of itself function. We want to find the composition to itself of the function. So this is x plus 2 divided by 3 of x plus 2. Here what I'm trying to say here x is replacing to whole of this one, and same for the 3 and 2, x plus 2 over 3 of x. Okay. No,
Yes.
no, I'm solving it. Here I'm taking the LCM to the above one. So our x plus 2 is as it is. Our x plus 2 is as it is plus. This is our 6 of. And after this, we are multiplying this one. This is 3 of x plus 6 of x and divided by 3 of x. And this 3 of x is cancelled to the this of 3 of x. Can you got it?
Yes.
Okay. No, we are solving this one. So, you know, this is x plus 6x. This is 7x plus 2 divided by this is 3 of x plus 6. Okay. So, can you get it?
Yes, you can you scroll down a little bit. I'm gonna write it down. So 7x
Okay.
plus 2,
Okay.
3x plus 6. Yes.
Yeah. So look at it here. Find the inverse expressions of this one. So look at it here. We want to find the inverse of that one function. We know the f of x is equal to 1 minus x of under root. And we can write it like this type. This is 1 minus x of under root. And we want to find the f inverse of x. And so we want to find the inverse of that one functions. Okay. Now we are taking the square on both sides. So taking the square y square is equal to 1 minus x under root whole of square. So square is under root. So this is y square is equal to 1 minus x. So y square minus of 1 is equal to minus of x. This is minus of x. If I'm replacing it, I'm rearranging it. This is minus 1. plus y also. Okay. So this is your minus of x, and this is minus. I'm taking the minus as common, so this is 1 minus y also. Okay, so this is minus x is minus minus cancel. You know, in our inverse functions we do the replacing x to the y, and x to the y is replacing, and y to the x is replacing. Okay, so this function is, this function is like becomes of this one, x is equal to 1 minus y r squared. So this is y is equal to 1 minus x squared, and this is our f inverse of x is equal to 1 minus x squared. Okay, can you got it?
Yes.
If you can go through it, I'm giving you the time.
Okay, sorry, good. Yes, sir. Done.
Okay, now we are moving to our D part. Uh, on the axis, like the ones here, the sketch, the graph of the f of x and f inverse of x. Okay, okay, it's mean he is demanding the sketches, the graph of the inverse of function and original function, and domain and range of the inverse of the function. First of all, our function is what f of x is equal to 1 minus x. And you know what I'm telling you, negative under roots, we are skipping that one. If suppose that we are setting x is equal to 0, x is equal to 0, it gives us f of 0 is equal to 1 minus 0 of under root. This is equal to 1. And suppose that if we are setting x to 1, this is 1 minus 1, 0, 0 under root is okay. And if we x is equal to 1, so f of 1 is equal to 1 minus 1. So this is equal to 0. And then we are x is equal to 2. So f of 2 is equal to 1 minus 2 of under root. This is minus 1 under root. Look at it here. This is our minus 1 of under root. So we skip it, this one point. And same for if suppose that we are put x is equal to 3. So f of 3 is equal to, 1 minus 3. This is minus 2 of under root. This is also, we skip that one point. Okay. No, we are
Okay.
checking. It's mean if we are put the positive points, we got the negative numbers. We got the answer is negative. It's mean we are here, but no, we are checking from the negative side. If we are setting x is equal to minus 1, so f of minus 1 is equal to 1 minus and 2 minus 1. And this is 1 plus 1, and this is 2 of under root. And suppose that if we are setting x is equal to minus 2, so our f of minus 2 is equal to 1 minus into minus of 2, and this is 1 plus 2 of under root. This is 3 of under root. And suppose that if we are setting x is equal to minus 3, so f of minus 3 is equal to when we are setting 1 minus and 2 minus of 3 of under root. So this is equal to 4 of under root. This is equal to 2. It's mean if we are setting our real line, here is a 0, here is 1, and here is 2, and this point is also skipping, this is also skipping, and this is also so on forth. These are all points are skipping, but from here this one side, this is the okay, this is the okay. So on the behalf of this one, what is the domain of that one functions? Domain of f of function is starting from the 1 to negative infinity. Can you got it?
Yes, you got it.
Okay. So range is what? You know, range is the output of the domain. And now we are, if we are setting our 1, if we are setting our x is equal to 1, we got 0. We got 0. Okay. And when we set our 0, we got 1. When we are setting our x is equal to 1, we got 0. So it's a range is starting from the 0, and check it here. When we are setting 1, this gives us the 0, 0. When we are setting 0, it gives us the 1. And when we are setting minus 2, it gives us the 2 of under root. And when we are setting minus 2, it gives us the 3 under root. And when we are setting, so it gives us the positive infinity, positive infinity. And our target was what? Our target was to find the inverse of to find the domain and range of the inverse function. But here I'm just finding the domain and range of the original function. So what should I do? uh, I'm trying to this one domain of inverse function is what? We shuffle it 0 to positive infinity, and our range of inverse function is what? This is the 1 to minus of infinity. So basically, what we are doing, this is the domain and this is the range. Okay, in inverse functions. Okay, can you got it? You can go.
Yes, I got it.
You can go through it.
So can you scroll down a little bit?
Okay.
Thank you. Huh? Yes, sir, I'm back.
Okay. So we are doing our second one problem. Hmm. Okay. Check it here. The function as defined f of x. So our function is f of x is equal to what x square minus 1. For x is greater than 0, find the expressions f prime f inverse of x, setting its domain and range. Okay. First one, we want to find the inverse of that one function, and f this is your function y is equal to x squared minus 1. So this is y plus 1 is equal to x squared. And we want to reduce this square, we take under root on the both sides. So our x is equal to 1. What? This is y plus 1. And in our inverse function, what we are doing? We are replacing x to the y and y to the x. So our x plus 1 of under root. So our inverse function is what? F inverse of x is equal to the x plus 1 of under root. Can you got it?
Yes, sir.
Okay. Now we want to find the domain and range of the inverse function. But going to the inverse function, we want to find the domain and range of original one function. The x square minus 1. Look at it here. In previous sessions, we already discussed that if our function is p over q format, this will, if our function is in p over q format, maybe this function will be the in this format, and it gives us the infinity format. And also if our function is negative under root, our function is, suppose that our function is in under root, it gives us the negative under root, and that's why we can also skip it here. But here this is the function is not in under root format, not in our p over q format. That's why its domain is, we can write it bluntly, its domain is what? Domain of that one function is minus infinity to plus of infinity. Okay.
Yeah.
And also its range is what? Its range of that one function is minus infinity to plus of infinity. And our target was what? Find the domain and range of the inverse functions. So our domain is, we can domain of f inverse, and also I'm writing it in combining format. Range of f inverse of x, it gives us the minus infinity to plus of infinity. This is going to this one and this is going to the this one. Okay. Got it.
Yes.
Okay, but before of this one, yeah, yeah. Look at it here. One thing is keep it in your mind. On the axis, like one sketch. Okay, so you can do the sketch. We already discussed this. We can make the table like this is x and this is y, and this is your graphical representation. In this side is x and y is positive, and this side x is negative, y is positive, and this is both x and y is negative, and here this is the x is positive but y is our negative, and we can draw the our points and we can combine them with the straight line. In this manner we can find the graph of that one functions. Okay, it's your job to do at homework. Okay, and if there is any confusion or any question, you will ask me in the next one session. Okay,
Yeah.
then we are hmm. Then we are moving to the on the axis like the ones below. Sketch the graph of the y is equal to f of x and f inverse of x indicate the geometrical relationship between the 2 points. As we already discussed, the f of x is equal to what x square and minus 1, and our inverse function is what we are already find it in above. This is x plus 1 of whole under root x plus 1 of whole under root x plus 1 of the whole under root, and if we are drawing the graph of our f of x is equal to x square minus 1, so this is your x, this is 1. When we are setting 0, this is the minus of 1. When we are setting 1, this is 1 square 1, 1 minus 1, this is 0. When we are setting 2, this is 2 square 4 minus 1, this is 3, and same for if we are setting 3, this is 3 square 9 minus 1, this is 8, and same for the if we are putting minus 1, this is minus of 1, minus 1, so here is what positive 1, 1 minus 1, this is 0. Also if we are setting minus 2 of this square, this is the plus of 4, 4 minus 1 is equal to 3. So these are the your order pair format. You can write it 0 and minus 1, and also 1 and 0, and also 2 and 3, and also 3 and 8, and also this is minus 1 and 0, and this is minus 2 and 3, and you can draw the graph with the help of these one order pair for. Okay, and here I'm just we are drawing our simple function. After this we are do that one table like that one table for the inverse one functions. Okay,
Yeah.
so is there any confusion regarding this one part?
No, sir, no confusion.
Okay, so I'm skipping some points for your homework. Okay.
Okay.
Okay. Here I'm just giving you the some clue points. Then we you can do this one part. The function f is defined. So our function for all values of the x, the graph of y f of x is given below. Explain the reference to the graph. Y does not have an inverse function. So our function is what f of x is equal to 1 minus x square, 1 minus x square. For all values of the graph y is equal to f(x), explain with the reference of that one graph why f does not have an inverse function. So why f does not have this one function? Can you tell me, CK?
Yes, sir.
I'm asking you the question, sir.
I I'll do the third one, sir. I'll try doing the third one.
Okay, okay.
I'll do 3A and B and tell you the answer, sir. Just give me
Yeah.
like 5 to 10 minutes.
Okay.